Good morning. I will explain sum of subsets problem. The problem statement is as follows. If there are n distinct positive numbers, also called as weights, it is required to find all combinations of these numbers whose sums are m. This is the sum of subsets problem. Explicit constraint: xi belongs to j, where j is an integer and j lies between 1 and n. Implicit constraints: sigma I is equals to 1 to k and wi is equals to m, and xi must be less than xi plus 1, where I lies between 1 and k. We will solve an example. Find the sum of subsets where n is equals to 3, m is equals to 6 and w1, w2, w3 are given as 2, 4 and 6. Solution: let us construct a state space tree. Under backtracking, state space tree is constructed in depth first manner. Given that n is equals to 3, m is equals to 6, w1 is equals to 2, w2 is equals to 4 and w3 is equals to 6. Initially, sum is equals to 0 and we will start with a root node labeled as 0, that is sum initial value. We will consider the weights w1, w2, w3, one each at a level. Initially, the first weight w1 is considered to construct the node at level 1. Here we have two options. First, consider w1 is equals to 2s. Here we are constructing the state space tree using depth first manner. So we will construct the node at the level 1 and we will label the node with the sum 2 plus 0 as 2. The resultant sum is 2. Now we will consider its children by considering w2 is equals to 4, that is the second weight s. Now the resultant sum is 2 plus 4 is 6. Now we will consider the third weight w3 is equals to 6. 6 plus 6, the resultant weight is 12. We will label the node as 12. Now we finished by considering all the three weights in the subset. w1 is equals to 2, w2 is equals to 4 and w3 is equals to 6. Now after completing the one path, we will backtrack to its parent. Now we have the other option for not considering w3 in the subset. So the sum is 6. So if the weight w3 is equals to 6 is not considered in the subset, then the sum remains 6. Now we will backtrack to the parent and we will backtrack to its parent at the root at the level 1. Now here we have another option by not considering w2 is equals to 4 in the subset. So that is no. So here the resultant sum is 2 plus 0 remains as 2. Now we have one more option by considering w3 is equals to 6, that is s. So 2 plus 6, the sum 8. Without considering w3 into the subset, we have the resultant sum that remains as 2 plus 0, 2. Now we finished with the other path with the other subset with considering a single element 2 by not considering 4 and not considering the third weight 6. So now we will backtrack to the parent and we will backtrack to its parent at the level 1 and also we will backtrack to the root level. Here we have another option for the w1 by not considering W1 in the subset. So the resultant sum is 0. The resultant sum is 0. So here we have at the level 2 where W2 is equals to 4. By considering W2 is equals to 4, yes, 0 plus 4, the sum of the subset is 4. So here we will construct in the depth first manner again by considering W3 is equals to 6, yes. So the subset is 4 and 6, that is the sum 4 plus 6 is 10. Now we will backtrack to the parent at the level 2, and we will have other option by not considering W3 into the subset. So the resultant sum is 4 plus 0 remains 4. Now we finished with all the 3 weights in this path. Now we will backtrack to the parent at level 2, and also we will backtrack to the parent at level 1. At level 1 we have another option for W2, that is not considering W2 into the subset. So the resultant sum is 0 plus 0, that remains 0. Now at this level 2 we have the option to consider W3 is equals to 6 into the subset. So if you consider W3 is equals to 6 into the subset, then the sum of the subset 0 plus 6 remains 6. Now by now we finished with all the 3 elements in the set given. So we will backtrack to the parent. Now here we have the other option for not considering W3 is equals to 6 into the subset. So the sum remains 0. So now we completed with the state space tree. So after constructing the state space tree, here we can observe that all the leaves in the tree are giving the sum of the various subsets that are formed with the given set. Here the subset that is used 2, 4 and 6. 2, 4 and 6. So the leaf with the label 12 represent the sum of the subset 2 plus 4 plus 6, that is 12. Now here the subset that is formed is 2, 4. So the sum of the subset is 2 plus 4, that is 6. Now here the subset that is used 2 and 6. And here the subset with a single element 2 where 4 and 6 are not considered. Similarly, here we considered only the elements 4 and 6. Similarly, 4 and a single element 6, and here the empty set. Here all the 3 elements are not considered, which results into a empty set. So the sum of the empty set is 0. So now we can observe these are the sums. The leaf node in the state space tree of a sum of subsets problem represents the sum of the subsets that can be formed with the given set. Now the answer state. We need to find the answer states for the given problem. The answer states are the states which satisfy the explicit constraint that is given. What is the explicit constraint in this problem? M is equals to 6. That is, the sum must be 6. So the states that satisfies the explicit constraints are with sum 6 here and one more state with this 6. So here the subset that can be used as an answer state is 2, 4 and 6. Therefore, answer states are 2, 4 and 6. This is the sum of subset problem.